Hey everybody, welcome to Algo Expert. In this video, we're going to be covering the question of the product sum. Spoiler alert, this is a classic recursion question. We're given what's called a special array, and we have to find the product sum of this special array. So a special array is defined as an array that consists of numbers or integers and or other special arrays. So right then and there, that should be a huge indicator that this is going to be a recursion problem or that this is going to be solvable using recursion, because the prompt itself is sort of recursive, right? If a special array can contain other special arrays, then that sort of implies a recursive approach to solving the problem. And so then we want to find the product sum of this special array. The product sum is the sum of all the elements in the array. So in the array that I've got in front of me, which is a special array, you would sum up all the elements. But when you get to another special array, like this one, right, 7 and minus 1, you sum up the numbers of that special array, but you multiply that sum by the depth of that special array. So like the actual input array, the full array here, you would sum up all the elements inside of it, and you would multiply that sum by 1, because that's sort of the depth of the initial array. Then here, the secondary array, you would sum the numbers up and multiply that sum by 2. Here in this other secondary array, 6, 4, and this other array, you would sum them up, multiply them by 2, but this other subarray inside of it, negative 13 and 8, you would sum those up and multiply them by 3. So hopefully this makes sense, and for this particular array here, you'll have to trust me that the answer is going to be 12, okay? The answer to this product sum is going to be 12, or rather the product sum of this special array. So how do we solve this problem? Well, like I said, we're going to do so recursively, but naturally, we're going to have to sort of iterate through this array and sum up elements, right? So we can start from there. We can say, starting from the left, going all the way to the right, just iterate through every element in the array and add them up. Probably we're going to initialize a sum to 0, add the elements up, and actually at the end, we're going to return the sum multiplied by the current depth that we're at, right? So for the initial array, this would look something like, we have the sum, which is going to be initialized to 0, and we start iterating through the elements, right? And we add them up. So we get to 5, and we say, okay, the sum is now going to be equal to 5. Then we get to 2, and we say, okay, the sum is now going to be equal to 5 plus 2, which is going to be 7. And then this is where we get to not a number, but a special array. And so here, as you can start to imagine, this is where we're going to sort of apply the recursive approach to solving this problem. We're going to say, if our element is an array, and so as a side note, for these two first elements, we didn't blindly add them to the sum. We first checked whether or not they were integers. But so if we're at a point where we are dealing with an array, then we're going to say, add to the sum the product sum of this special array. And so here we do the recursive call. So here we say like, oh, this is an array. Call the recursive method product sum, which we'll define in our code, on this array. And of course, the key thing is, remember, the multiplier increases as you go deeper and deeper in these special arrays. So probably we want our recursive method to have another parameter, a multiplier parameter that we pass to it, and we add 1 to that multiplier, right? So if the multiplier m is equal to 1 at the very beginning in our original array, when we get to this special array here, we're going to call our recursive method on it, the product sum method on it, and we're going to pass in m plus 1 to the recursive call of product sum on this array, okay? So what this would look like is we'd say, okay, we are on the first, let me rearrange this. We're on the first call of the method, which is on this sort of array right here. Our sum is equal to 0. Our multiplier m is equal to 1. That's the initial multiplier because we are depth 1. We start at 5, like we said before, so we add 5 to the sum. So the sum is now 5. Then we move on to 2. We add, this is not an array or a special array, neither was 5, so we add 2 to the sum. We're now at 7, right? This is where we were at before. And now we say, okay, we're at this array, this special array right here. So we're going to jump into it and do a recursive call. Whoops, that is not what I meant to do. We're going to do a recursive call here where the sum is going to be initialized to 0, but m is going to be equal to our previous m, which was 1, plus 1. So m is going to be equal to 2 here. And we go into the 7. The 7 is a number, so we add it to this sum. So this sum here is 7 now. Then we go to the next number, a minus 1. So add it to this sum. That's going to be 7 minus 1, 6. And now we're done with this special array, right? We're at the end of the special array. So we sort of get out of the recursive call, return the sum that we just calculated, 6, multiplied by our multiplier m, which happens to be 2. And so now we've got 6 times 2, which is going to be equal to 12, and we can put the 12 right here. So we know that this here, the product sum of this, is equal to 12, and so we can add 12 to our initial sum, which was 7. So we're going to say 7 plus 12 is equal to 19. Then we move on to the next element in our original array, which is 3. So that's going to be a number. We add 3 to 19, so that's going to be 22. And then the next element is, again, an array, right? So we're going to say this, right, is going to have a sum of 0, and m at first is going to be equal to 2, because we called, and maybe I should give myself a little bit more space here. So I'm going to just erase this. I'm going to erase this and continue that line right here. Here, right, we've got the sum, which is equal to 0, and m, which is equal to the multiplier that we had right here in the sort of parent subarray, which is our initial array, 1, plus 1. So 2. It's the same multiplier that we had for this other subarray, which makes sense because that was sort of a sibling of this. Okay, so we start iterating in this. Right now we're in the recursive call. So we've got a number, 6, so added to the sum. So the sum is now 6. Then go to the next number, and now, whoa, we've got another special array. So we're going to make the recursive call here, right? I'll just underline this. And here we've got a sum of 0, and we've got m. Actually, let me undo all this and put it above so that I have more space. So we'll say this subarray has a sum of 0 and a multiplier of whatever our current multiplier was, which was 2, right? Because our multiplier for this array was 2 plus 1, 3. So now we've got a multiplier of 3. So then we've got a number, negative 13. So we can add negative 13 to our sum. So that's going to be negative 13. Then we've got a number 8. So we can add that number to negative 13. So that's going to be negative 5. And now we're done with this array. So we return the product sum of this array, which is going to be our sum, a negative 5, multiplied by our multiplier 3. So negative 15. So this is going to be, we'll just erase that and put it here, negative 15. And so our sum here is going to be 6 plus negative 15. So 6 plus negative 15 is how much? Negative 9, I guess. And then finally, we've got a number, 4. Add 4 to negative 9. That's going to be negative 5. And then multiply that negative 5 by the multiplier, because we're done with this array. So that's going to be negative 5 times 2. That is going to be negative 10, right? So we can erase all this and say this entire subarray, which I guess ends at the 4 here, right? This is negative 10. And so we can add this -10 to our sum here for the initial array. Now we're back up all the way to the first recursive call. So 22 minus 10 is going to be 12. And since we're at the very end of our initial array, we can return 12 multiplied by our initial multiplier, which is 1, and that's going to be 12. And that's our answer, right? That is the answer of the product sum of this array. So that is how the algorithm works, right? You iterate from left to right in the array. If you're dealing with a number, you just add that number to our sum, which we've initialized at 0 at the beginning of our recursive call. If you're dealing with a special array, then you call the product sum method on that special array and add 1 to the multiplier that you pass, and you use your current multiplier plus 1. Add whatever you get from that call to product sum to your sum, and then finally return it multiplied by the multiplier. And you get 12. As far as, for this example, of course, as far as complexity analysis goes, the time complexity is going to be O of n. Now, it's really important here to define what n is. N is not the number of elements in the original array. N is the total number of elements in the original array, including all of the elements in each subarray, and then each of their subarrays afterwards, and so on and so forth. So here, O of n would really be 1, 2, 3 for this entire subarray, 4, 5, 6, 7 for this entire subarray, 8, 9 for this entire subarray, 10, 11, 12, and that's it. So it would be O of 12, I think, in this one, which would be O of n total, but you have to define what n is. Here it's the total number of elements, including the sub-elements. As far as the space is concerned, we are not really using that much extra space in terms of storing variables or storing other lists with regards to the input, but we are making recursive calls, right? So we're going to be using up space on the call stack. And how many recursive calls are we going to have sort of at once at any given time? Well, it's going to be whatever the maximum depth of subarrays is, or special arrays. In this case, it's going to be 3, right? Because basically it's the maximum value of your multiplier at any given time. And here it's 3 because we've got our main array, then we've got a second array here with a third array inside of it. So there's going to be a point where we've got 3 recursive calls sort of happening at once, taking up space on the call stack. So that is going to be, we'll call it O of D, where D is the depth of the subarrays or the special arrays in your input array. Again, here it's really important in an interview to explain to your interviewer what these variables n and d represent, because just saying O of n doesn't actually really make sense. And if someone assumes that you mean the total number of elements in your original array, that's incorrect. So that's it for the conceptual overview of this algorithm. Let's see what it looks like in code. All right, so we've got our product sum function defined. It takes in an array, or a special array rather. And the first thing that we're going to want to do is to transform this product sum method into our recursive product sum method that we're going to use. And if you remember from the conceptual overview of the algorithm, we said that we want to also pass in to this recursive method the multiplier parameter, right? The value, the integer value that we're going to be using to multiply the sum of any given special array. So we'll add in the multiplier parameter here, multiplier, and we're going to initialize this multiplier to be equal to 1. In other words, the first time that this method gets called and doesn't really know about the multiplier, initialize it to 1, and then we'll make sure to pass that value for any future recursive call that we make. Now, once that's done, we can start with the actual real meat of the function. First thing we do is we initialize our sum variable, which is going to be initialized to 0. So anytime we're calling this recursive method, we have a new sum initialized to 0. And then we just iterate through the array that we're calling this product sum method on. So we say for element in array, and I'm calling this element because the element could either be an integer or another array, another special array, so we'll just call it element. And here we want to do our check to see if we're dealing with an integer or if we're dealing with another list, right? Another array, another product sum, or another special array. Now, in Python, to check if something is a list, we can just do if type of element is list, right? In your in your language of choice, you can use whatever the built-in method to check if something is a list or an array is. In JavaScript, I think it would be array.isArray. The one key point that I want to make here is that you may find yourself in an interview not really knowing what the built-in method or way of checking if an element is a list is. And that's totally fine. Like, these are things that you're likely not going to be doing on the job that much. And what you can just say to your interviewer is, there's a way to do this built into my language. I forget the method. I think it's that. I think it's array.isArray or whatever. If I weren't in an interview setting, I'd probably look this up on Stack Overflow or on the documentation online. But the point is here, I would check whether or not this element is a list. And most interviewers are going to be totally fine with that, okay? Because the point of the matter is not that you remember that to check in Python if an element is a list, you have to do type element is list. That doesn't really matter. Like, that's really a 2-second check on Stack Overflow. In fact, when I was writing this, I looked this up on Stack Overflow because I didn't know how to check if an element is a list in Python. But the point is, just voice that to your interviewer. It will really go a long way for you, and you'll be able to unblock yourself on something trivial like this. So if the type of the element is a list, this is where we want to do our recursive call, where we're going to do sum plus equal to product sum of the element, which is a special array itself, and we pass in the multiplier plus 1, right? So this is the recursive call. Sum plus or equal to a recursive call to product sum, passing in the element and passing in a multiplier plus 1. Otherwise, if we're dealing with a number, right, an integer, and we were told in the prompt that we can expect either integers or special arrays, so this else here is fine. Otherwise, we just add the element to the sum. And that's it. Now we've got our sum. We just return the sum multiplied by the multiplier, and we are done. Recursion will do its magic, and we'll find the final product sum for the original array in no time. And so, as you can see, this algorithm is going to run in O of n time, where again, n is all the elements in the array, including all of the elements in each subarray, sort of recursively in the array. That's really important, because again, we are ultimately iterating with this for loop through every single element and sub-element. So that's why it's O of n time, where n is defined as I just did. And then for the space complexity, it's going to be O of d space, where d is the depth of the largest depth or the greatest depth of the subarrays, because again, you can imagine that this product sum here is going to be called, you know, d times at one point in a single sort of instance, right? And we're going to have d calls of product sum on the call stack. So it's important to remember that this is going to be O of d space. So that's it for this question. This is the product sum. Very classic recursion question. Hopefully this really helps you solidify your recursion skills, and I'll see you in the next video.